Yes, well, maybe I say a few words about myself first. I'm a native of Estonia, which is one of the Baltic states in northeastern Europe, now under Russian occupation. And I left Estonia just before the end of the war, and just before the Russians took over, 1944. Went to Germany and did my undergraduate work at the University of Göttingen in Germany. And 1952, I came to America and went to the University of Texas, where I did my graduate work with George Watt at the University of Texas in Austin. And got my PhD in 1956 there in inorganic chemistry. The work was actually in liquid ammonia, complexes in liquid ammonia. And then I had 1 year postdoctoral experience at Northwestern University in Evanston, Illinois. I worked with Professor Selwood for a year on magnetism and chemisorption. Then I went to Mellon Institute, where I stayed 7 years from 57 to 64. And there I discovered most of the things I have discovered. There we had a very excellent situation for basic research. In fact, there were no duties, just to do whatever one wanted to do. And while I was interested in low-valent transition metal complexes, that was part of my thesis work already. And well, a few people had used phosphines at that time, Malatesta in Italy and Chat in England. And so I thought I would try some of the phosphines with osmium, especially because that was my thesis work concerned with osmium. And so I got involved with tertiary phosphines and a number of transition metals. And I had done actually no work in catalysis all before that, except with Selwood we studied some chemisorption which was related to catalysis to some extent. Well, anyway, the discovery of the iridium complex, as most discoveries are, was completely accidental. We were trying to just make a low-valent iridium complex of phosphines, and a quite peculiar compound precipitated, which had a CO stretching frequency, which we didn't suspect because we didn't use carbon monoxide as one of the reactants. And then quite accidentally we discovered the reaction of this iridium complex with HCl. Then I suspected that it may also add hydrogen, and it did, and the reaction with hydrogen was reversible. And then we recognized that this complex may have a potential in catalysis. And the oxygen complex was discovered also purely accidentally. In fact, we recognized that the iridium complex has a tremendous reactivity toward a number of different molecules, and then we tried almost anything that was on the shelf and let them react in air. And next day it turned out that half of the reactions, which we used different reagents, were identical, and actually these products were all oxygen adducts. And then we recognized that the compound reacts with oxygen, and also subsequently that it reacts reversibly with oxygen. Well, that was the beginning, and as you know, then the compound became quite popular, and a lot of people continued these studies, applications in homogeneous catalysis and so on. So that was roughly the beginning of this type of work.
How does it feel to have a compound or a class compounds known as vascular complexes?
Well, I got used to it already, so at first it was of course quite interesting. And now, as you know, a lot of people are working with this compound and a number of derivatives. And of course one of the basic properties of this compound was that it was very easy to handle. The reactions were quite slow. The compound itself is not a active catalyst, but it's a model compound, so the reactions are slow. You can follow them and isolate intermediates, and so therefore it continues to be, I think, a model compound. In fact, we're using it still in different types of applications now.
How would you describe working with Professor Selwood?
Well, I liked him very much. I spent there 1 year, and he was a truly very nice gentleman. So I enjoyed working with him very much.
What year was this?
That was 56, 57. And I just heard recently that he died a couple of years ago.
Yes.
Was it a couple of years ago?
I think it was.
Yes.